Welcome back to Computer Science 4303. Today, we are going to be talking about Assignment 3, which I think is probably the coolest assignment, other than the project stuff, so I hope you all enjoy that. And just remember that if you're watching this live, then Assignment 2 is due tonight, so make sure you get Assignment 2 done and submitted by midnight. And Assignment 3 will be available just after Assignment 2 is due. And today there is a quiz. It's 2 p.m. if you're watching this live. The quiz will be available at 5 p.m. So it's not going to be available at 3, but it will be available at 5. And the reason for that is I just wanted to give this lecture and see what I'd be saying in the lecture to see what sort of questions I actually want to give on the quiz. So going forward, and I'll make a D2L announcement about this, the quizzes will be released at 5 on the day rather than 3 p.m. on the day. Okay, so let's get into the assignment. Assignment 3 is, I'll pop open this here so we have a bit of a darker background. We have a bunch of stuff to go over for Assignment 3, but first, let's give a live demo of what the assignment is going to be like. So here is my solution to Assignment 3. And Assignment 3 is all about procedurally generating a universe. So we're going to be generating star systems, and inside those star systems, we're going to be generating planets, and on those planets, we're going to be generating terrain. So here I give you a bit of a user interface. So this user interface comes complete with the assignment. You don't have to do anything with the user interface in order to get full marks. But in this user interface, you can see here that I've generated a bunch of star systems, and you can right-click and drag around this to see, you can just keep going in this universe. You can zoom in and out with the middle mouse button. You can turn on and off the grid with the G button. And so, for example, if I zoom out here, you can see that it's a pretty big universe. Okay? So we can generate this infinitely large. So as long as your system can handle it, you can generate it. And just to show you, a little extra feature here, you can like save a little area of this universe. So if I hit the K key, that will actually save and show you where I was zoomed in at. Okay. And you can see just how small that is in comparison to like what we're actually generating here. If I hit the L key though, it will go right back to that area. So you can zoom in, you can save areas, but this saving of an area doesn't have much to do with an assignment. It's just for the user interface. So as we're looking around the universe here, you can see as I mouse over stars, there's actually some information associated with them. So for example, this star says the name of the star is Nu Eta 66. You're going to be generating names for your star systems, and this is a randomized generated name that I did. It has a seed, which is an integer value that we're going to be using to calculate some other things with. It has a position, a radius, a temperature, and some number of planets. So this one has 1 planet, this one has 2 planets, this one has 8 planets. So if we click on this planet with the left mouse button, at the bottom here, you see all the information, that's a star. You see all the information about the star, and you see a whole bunch of planets down here. Now, if I use the A and D keys, I can move back and forth between these planets, okay? So these planets have a number of moons. All of those are randomly generated. And then if I click on a planet with the space bar, then I actually go to that planet's surface and I can see the surface of the planet. Okay, so let's just have a look at this. So this planet has this little like lightning bolt shaped thing up here in the top left. And then there's this little square here. So just remember like this structure up here. So if I exit out of this planet, which star am I currently clicked on? Oh no, I forgot. Let's see here. Crap, I forgot which planet we are in. That's okay. The important thing is, if I go generate another planet, and then I come back to that original planet, it regenerates the exact same terrain, okay? So even though there is randomness, we are using that star system's seed to regenerate the exact same planet from what we had before, okay? So, yeah, someone said Nu Eta 66. I get that, but I can't remember where I clicked on it. So, that's okay. So, let's just click on another planet here. This Zeta Omicron 983. So if we click on this planet, or this star, you can see all the planets down here. Then if we click on this star, we can see it has one planet, but if I click back, it has the same planets that it had before. So let me look at the first planet here. You can see it's quite a densely populated pink planet. Then I'm going to look at the second planet. It's more of a sparsely populated green planet. If I go generate this star's planet, it's a very, very small planet with a cave-like structure. Then I go back to this one and regenerate that pink one, and it's the same as it was before, okay? But none of that is ever being stored. It's all being dynamically generated, okay? The only time we ever store anything is while we are looking at the planet's surface, it stores a copy of the planet's surface. But as soon as we leave that planet view, it destroys that, okay? And then when we go back to that planet again, it regenerates that planet's thing. So, actually, let me move my camera down just a little bit because it's covering up part of the user interface here. So that's the assignment. You are going to be writing the code that procedurally generates this whole star system. Okay, so I think I've kind of explained it. It's a pretty simple, intuitive explanation. But now, as always, we're going to go over the README file to give all the details of exactly how this works. So let's do that. Here's the README file. Oh, I'm blind. Okay. So, assignment 3. The standard intro talking about how you only zip and submit the source directory. So please don't create additional files. Just zip up what's there and submit that. All right. So the program specification. In this assignment, you will be computing an infinite universe using procedural content generation. Your exact tasks are as follows, with sample code provided in universe.cpp. So universe.cpp is going to be the file that you're going to be spending most of your time in, and we'll get to that eventually. So the first thing you're going to do is star system generation. So your first main task is to implement star system generation by generating pseudo-random numbered values, which you then use to assign various properties of a star system. The star system struct can be seen in universe.h, which contains several variables that are all commented within the universe.h file. So let's go look at universe.h real quick. Here is the universe.h file. It contains a planet structure. We'll get to the planet structure in a bit, but it also contains this star system structure. So this is a struct. A struct is essentially just a class where everything is public. Okay, so you don't need any accessor variables. So here we have all the variables and functions that are related to a star system. Okay, so here the first two are going to be the X and Y position of the star in the universe. Okay, and I'll get to how that is going to be given to you. But the X and the Y position of the star system in the universe are given to you by the user interface. So these will be given to you. You don't have to set these. But the rest of these, you do set. Okay? So there's going to be a seed value. Let me zoom in a little bit more. And I'll move my camera back up. Just give me a second here. There we go. All right. So that's planet again. Where'd star system go? Here we are. So the X and Y values are given to you. There's a seed. So this is the random seed that you're going to be generating for every star system. And that seed is going to be used to generate the rest of the data for the star system. You're going to give this star system a name. You're going to give the star a color. You're going to give it a radius, a temperature, and a number of planets. And then you're going to generate some number of planets. And that number of those planets are going to be stored inside this planet array. Okay? And then you're going to have some functions to be able to get the data from here. So you have getName, toString, and exists, essentially. So this is the data that's associated with a star system. And now we'll see what you have to do in order to generate that. So all of the code for star system generation should be performed in the function universe generate star. And generate star takes in an X and a Y location. And that function is going to generate and return a star system object that is to be drawn and interacted with by the user interface. The user interface will call this function for each XY location on each frame that the program is running, with no persistent storage for any of the star system objects. This means that the code that generates this object must be as fast as possible. This is why the getName function generates the name of the star only when the function is called, so that we're not needlessly generating the names of stars when they're not being displayed. We'll get to that in a little bit. The color of the star that you generate should be based on the temperature of the star, with the specific values given inside the universe.cpp sample code. An image has been included with the assignment in the root folder of various star temperatures and their associated colors. So what you're going to do is you're going to generate a randomized temperature for your star, and then based on the temperature, you're going to give it a color that is within this range of colors, okay? So you're not going to be having like pink stars or green stars. You're going to be creating stars within this range of colors. And if you look at the actual solution, you can see that all the stars are actually within this range of colors. So it's from almost white, blue, up to dark red, okay? So for this task, you must work within the following functions. So the universe generate star function and the star system getName function. All right. 2 more notes before we dive into the code and explain exactly how this works, because I know it's a lot of information to just read up front. A note, the UI will make calls to various XY locations within the universe based on a grid system. Since making calls to every possible XY location would be far too slow. The size of this grid can be seen in config.hpp, and by default is a square with sides of size 256. This will not change in the marking process and should not be changed unless you're testing a specific bonus feature. So what does that mean? Well, here's what that means. Let me switch over to the Blackboard. Alrighty. So essentially what I've done, let me go back here. If you look at this universe, the universe is broken up into this grid structure. You can see maybe it's a little bit hard to see. It's like light gray lines in the back. So in order to randomly generate stars, instead of just saying, okay, give me 1,000 stars and place them in random locations, what we instead do is break the universe down into a grid, and then we iterate over that grid and say, should there be a star in this grid location? And the way we do that is actually pretty easy. So let me show you that. All right. So let's say this grid here is our universe. All right. So we are going to iterate over this grid, let's say from here down to here. So this might be the viewable area of our universe. Okay, so let me draw a line here. So what happens is the user interface figures out which portion of the grid is currently viewable to the user, right? And if we zoom in further, there's less things visible to the user. If we zoom out, there are more things visible to the user. And so what it will do is it's going to iterate over each one of these grid cells, and it's going to essentially roll a dice, and if the dice is lower than a certain number, it's going to generate a star there, okay? So let's just say that that number was 50-50. So we have a 50-50 chance of each star, of each grid cell containing a star. So essentially what we do is we're going to come in here and we're going to iterate over each location and flip a coin, right? So if it's heads, we draw a star. If not, we don't. So we start up here. Maybe it was tails, tails, heads. Okay, this is heads. I'm going to draw a star here. Tails, heads, heads, oops, heads, heads, right? So we're generating a random number for each grid position. And if that meets a specific condition, either heads or tails or, 10% or 20% or 90% or whatever, that's where we're going to be putting stars, essentially. So that's essentially how the whole system works. It just iterates over that grid, rolls a random number, and generates a star if that random number meets a specific condition. So let's go back and we'll see that condition here. So in our config.hpp, which is globally readable by the whole thing, you're going to have this star exist chance, okay? And this star exist chance is going to be 10, so that just means 10% of the grid cells are going to be stars. And there are some other things here which I'll show you in a second. So as the README file says, you're going to be doing all of this inside the universe generate star function. So let's go over to universe and we'll have the generate star function. Okay, so this function takes in the XY location of that grid. All right, so if we were like at this position right here, that would be 0, 1, 2, 3, 0, 1. So this would be 3, 1 in the universe. However, the XY locations in the actual universe are going to be much bigger and much smaller. Okay, so it's going to take in an XY location, and then it's going to do everything we said to generate that star and the planets for the star. So what we're going to do is we are going to generate a star at that location, okay? And so each position on the grid will contain a star. We set the X and Y location of that star, and we're going to set the seed of that star. And it says here, call the Lamer RNG function to set the seed based on the X and Y location. And if you recall a previous lecture where we talked about that Lamer RNG function, if we go up here to the very top of universe.cpp, we see that Lamer PRNG function. All right, so we have that Lamer PRNG function, and inside that function, let me actually just go back to my lectures here. I want to bring them up for you. How can we take this function, which takes in one value, and turn it into a function that generates two values? Well, let me show you here. Alrighty. And this lecture at the very bottom. So this is the function that we have inside our code right now. But let's take this and put it over here. All right. So we've taken this function and we are essentially just doing what we have in the notes. Okay. So go back to that. That lecture to watch why we're doing this. And then in order to use this function, all we have to do right here to call the Lamer RNG function is just say, okay, this is this. We call Lamer2 with X and Y. That's it. So that's all we would have to do to do that part of the code, to set up the seed for this star system. Now, we'll be using this function again later, but I'll get to that when I get to it. Alrighty. So, here is the part in the code where you would actually set the properties of the star system. So the way that the user interface works is that each of these grid cells actually contain a star system. However, only the ones that sort of rolled true, should exist, have a radius that's bigger than 0. Okay? So even though there's nothing shown on a lot of these grid cells, for example, even though like this one is blank, 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 there is technically a star system there, like an object is living there. However, it doesn't have any properties. Okay? So how do we set those properties? Well, this is what we're going to do right here. So if I run the code that I give you, not the solution code, but the actual student code, you're going to see something very, very different than the solution. And you say, oh my God, what is all this mess, right? This is just a bunch of, it's a grid of planets. Well, what I've done here is just given you some sample code, right? And this just says, okay, if x divided by 10 plus y divided by 10 mod 16 is 0, then a star should exist there. So let's just change this and see what we can do. So we're going to be, let's just say, if false, then we're going to generate a planet. So this should be all blank, right? So now our solar system is completely blank. If we set it to if true, then our solar system should be completely filled with planets, right? So this is the function. Apologies if my bitrate went down. This is the condition here that says whether or not a star should actually exist. So what we're going to do here is we're going to say, okay, how can I actually generate the correct probability of a star existing? Well, we're going to look over here, and we're going to look at this config star exist chance, okay? So let's just say that I'm back here in universe.cpp. So I'm going to say int random. So this is my random number. And I'm actually doing this part of the assignment for you because I want to give you an example. So this is going to be rand. We can use rand. I know it's not completely secure, but it's fine for the assignment. And this is rand mod 100. Okay? So this will give me a number between 0 and 100. Now I can say if that number is less than star exist chance, then I want to actually generate a star in that location. So if r is less than config star exist chance, then I'm going to generate a star. So remember, this is the condition that actually creates a star. So that's what I want to do for the assignment. And you can basically just copy and paste that and it'll be correct. Uh-oh. What's happening here? That's not what I want. Sorry, I should have put a trigger warning there, but essentially what's happening is I'm generating a new random number on every frame. So 60 times per second, it's regenerating all that stuff, right? So how do I fix that? I don't want it to be random every frame. I want it to be random, but be the same every frame, if you know what I'm saying, right? I want that universe to be generated and then not change every frame. So what I'm going to do is the following. Let's use this lamer PRNG function to generate the randomness for us. It returns a random 32-bit integer, which is what we want, and it takes in a seed. So if I give that the same seed every time, it's going to generate the same random number every time. So instead of using rand, which will give me a different number every time, or instead of, I could do this srand 0. That will seed rand to make it reset every time, but that's really slow. We don't want to do that. Okay. I'm going to use this lamer PRNG function. Okie dokie. So let's say that this now is lamer PRNG, and I'll just give it some random seed, so I'll just give it 0. So I'm going to call this lamer PRNG function. I pass it in whatever seed that I want, as long as it's constant, and I'm going to take it mod 100. And now this r less than config star exist chance. If this is between 0 and 100, and this is currently 10, then hopefully 10% of our stars are going to exist. Uh-oh, what did I do wrong? Well, we're going to debug this live. If anyone sees what I did wrong, let me know. I'm going to print out this R value. I love coding live. You seed 0 and use the first random every time. Yeah, I still don't see why that should not give me a random number. It's giving me 0 every time. Okay, let me put in some randomized value here. Oh, it's independent of X and Y. You're right. Okay, so I'm going to pass in... Oh yeah, I can just use the stars. I'm an idiot. Sorry about this. So the random value is going to be the star's seed, because that's what I just did. Right. Brain fart. There we go. Okay. So, apologies. Thank you, random person in the chat, for telling me that. So we've already generated a random number that's based on that grid, and that is the seed of the star, right? So I forgot all about that, and I don't know how. Huge brain fart. So I didn't read it. What is wrong with me today? So this is a very rare case of me getting things completely wrong. So if this condition is true, we will generate the properties of the star system. Otherwise, the default star will return a radius of 0, causing it to not exist. You should use the star's seed value to do this computation. Well, we all have bad days, right? So we use the star's seed value. We modulus that to 100 in order for this 10% chance to actually make sense. And then we use that to give a 10% chance of a star existing. So if we run the code again, we have about 10% of the stars existing. And it's the same on every frame because we have calculated that star's seed value based on the X and Y. All right. Well, apologies for that. That first thing I did, don't listen to me there. Okay. So now you can just do this. That part has been done for you, but I'm not going to do the rest of the assignment for you, but I am going to explain how. So all of the randomized properties of the star system should now depend on that seed value, right? Because we're going to be calling this Lamer RNG function to generate randomness for us, and that star's seed value is going to be used to do that. So what I do here is I set the star's radius, right? And this radius is currently just equal to the grid size over 2. So if you look, when I run this assignment, all of these stars are going to have the exact same radius, right? But that's not what I want. So the last thing I'll do is just set the radius for you to see how you might do this. Okay. So I want to set a radius randomly between the min and the max radius. So if I go over here to config, I see min star radius and max star radius, right? So I had some code in the slides to show you how to generate a random number between min star radius and max star radius. So let's generate a random number here. So we have star.seed. So I can use the Lamer RNG function to do something interesting. So I can let's use Lamer2. If I want to generate, let's say, a random number using that, I can say Lamer2 star.seed, and then I'm going to give this like a 0, for example. The reason I'm giving this a 0 is because I don't necessarily want to get the same random number every time. So if I call Lamer2 or Lamer with the seed of the star, I'm going to get the same number every time back from that. So if I called Lamer with the star seed for the radius, then I'd get the same random number as if I called it for the temperature or for the color, etc. So basically what I want to do is whenever I'm setting a temperature, whenever I'm calling any randomness here, I want to give it a different value every time. So the first random number that I generate, I'll give this a 0. The second random number I generate, I'll give this a 1. And then this will guarantee that the number that I'm getting back from here is different every time. Okay? And then I'm going to take that and, for example, let's say I wanted that number to be between 0 and 20. Now I actually want it to be between 8 and 128. So let's just make it between 0 and 128. Then this will generate a radius between 0 and 128. So if I go run my code now, then I get stars with different radiuses. Okay, so these will be random between 0 and 128. However, I actually want this to be between 8 and 128. So I could say config max star radius, right? So this will be between 0 and max star radius, but I want it to be between min star radius and max star radius. And if you look back at our slides, I think I gave you the code to do that. Yeah. So here in the slides, given a range of min and max, here is the function to do that. Okay. So in here for max, you would use max star radius, and for min, you would use min star radius, and the rand, you would use the lamer2 function like I just showed you. Okay. All right. So that's how you do that. And every time you want to actually call to set a new property of the star, you're going to use random number generation using the lamer2 function. Okay. So let's just leave that like that for now. Let's make this a little bit smaller so we don't wrap around. Then you're going to set the temperature. But the temperature, we actually want to be, between two values, min star temp and max star temp. And based on that temperature, we want the color to be from red to yellow with a min temperature of 6,000. With a max temperature of 6,000. So let me just show you how you would do that. Here, I've just set the color to white no matter what. But let's say we want to set the color to completely red if the star's temperature is less than 6,000. Okay, so I'm just going to move this up here. So what this logic is now doing is it's setting the star's color to white, but if the temperature is less than 6,000, it sets it to red. And so let's run it again. And so there are just a few stars whose temperature is less than 6,000, and so this is set to red. Similarly, if it's less than 10,000 but not less than 6,000, I'm going to set this to what is green and blue. I can't remember what green and blue make. Oh yeah, teal. So those are teal. And down here, let's just show, okay, well, if it's not less than 10,000, then it's going to be red and green, which is yellow. All right, so now all of our stars have a color, but they're the wrong color, right? So here is the color that I want your, oops, this is still maximized. Here's the color that I want your stars to be. So if it's less than 6,000, it's going to go vary in between these colors. If it's between 10 and 6,000, it varies between these colors. And then if it's greater than that, it goes up toward blue. So here it says, if the temperature is less than 6,000, the star color should fade from yellow, fade from red to yellow from a min temperature up to 6,000. If it's less than 10,000, it should fade from yellow to white from 6,000 to 1,000. Oh, sorry, that should be 10,000. And if it's less than or equal to the maximum star temperature, the color should fade from white to light blue from 10,000 to max. So how do we actually make the color fade like that? Okay, well, I'll show you an example. So let's say that we want the color to be between white and black from 0 up to 6,000. Now I'm just showing you this one example just so it's enough to show you how you would go about doing it, but not actually solving the problem for you. So instead of actually going from red to yellow, let's just go from black to red. Okay, how about that? So if we want 0 to be black, so 0 equals black and 6,000 equals red. Okay, so how would we figure out what shade of red we want to make this thing? Well, the first thing we could do is we could actually figure out where on this line currently is this number. Okay, so let me go back here. Let's say we are going to have black over here at 0, and we're going to have red all the way over here at 6,000. So this is temperature 0, this is temperature 6,000. So we're basically going to take wherever the temperature is, and we're going to divide it by 6,000 to get how far along this scale that we actually are, right? So let's do that. So ratio, that's going to be how far along we are between 0 and 6,000. That's going to be star.temp divided by 6,000. However, these are currently integer values, so I'm going to make sure that I'm doing floating point division here. Because if I take a number that's less than 6,000 and divide it by 6,000, if it's integer division, I'm just always going to get 0. So now what I'm going to do is I'm going to set the red channel of the color based on this ratio. So I want it to be black, which is 0, 0, 0, up to 255, 0, 0, which would be red. So what I'm going to do is just going to take this value and multiply it by ratio, and then convert that to an integer. So what we should have now is based on the random temperature that I gave that star, it should be black if it's 0, it should be red if it's 6,000, and it should be a smooth gradient in between. So let's just have a look, and we should have various colors of red stars. See that? So that's how we would go about doing that. Cool. Now, the way I did it here was just the star's temperature divided by 6,000, because the minimum was 0. However, we actually have a different minimum temperature over here. So make sure you're going from the minimum temperature to 6,000, not from 0 to 6,000 when you do that sliding scale. Similarly here, you're going to be taking the value between, well, let me just show you an example. Here, this ratio, well, it's going to be between 6,000 and 10,000, right? So you can't just say float ratio equals star.temp divided by 10,000, right? Because your range is between 6,000 to 10,000. And so if you're right here at, say, I don't know, like 7,500, you're approximately like 20% of the way through this range, right? So you should take that into consideration of your calculation. So just, I don't want to do it for you though, because that's part of the assignment. So that's how you set the color of your stars. Alrighty. Now that you have the star's temperature and color set, that's pretty much it for the star. You set a radius, you set a temperature. Based on the temperature, you set the color. Now you have to generate some number of planets. So let me just run this again. And I'll show you that each of my planets, when I hover over it, currently has each of my stars has 8 planets, and they're all the same. Right? Okay. So let's change that. The reason they all have 8 planets is because the number of planets here is set to 8. So if I do the same thing, where I come up here and I take the star's seed, right? Lamer 2, star seed, and then maybe this would be 3 or something. And then mod 8, or mod 9, I guess. Well, okay, what's the config? Max planets, so config max planets. Let's go through here. Now what you'll see is all of my stars have been given a random number of planets. So if I click here, this one has 3, this one has 6, this one has 1, this one has 1, okay? So now that I have that done, I'm going to do basically the same thing that I did for each planet, or each star, but now I'm doing it for each planet. So the star has been given a random number of planets, and then for each of those planets, I'm going to generate a planet object. I'm going to generate all of the properties of that planet, and then I'm going to add that planet to the vector of planets for that star. Okay? So let's go through what we're generating for each planet. So I'm going to generate the planet object itself, then I'm going to generate a seed for that planet. So the seed for that planet, you can just generate the same way with the Lamer2 function based on the star. However, each of the properties are then going to be set based on the planet's seed, okay? So down here, for example, where I set the planet's seed, you are going to use the star's seed to set the planet's seed. Then, whenever you set the properties of the planet, you're going to use the planet's seed for that, okay? And the reason is, you're setting these, this is P. You're setting these properties unique to each planet, not unique to each star. Otherwise, if you use the star's seed for the radius of the planet, then all of your planets are going to have the exact same seed, or the exact same size. Okay? So make sure you're using the planet's seed for that. Okie doke. Oh, keep in mind that you actually want to have a different number passed in here for each of the planets. So you might have something like 3 times I, or 3 plus I, or just I, or whatever. But make sure you're generating a different seed for each of the planets. So let's just go with what we have here and see what this is going to be. I don't know, mod, what we have, config max planet radius, right? So we're going to generate this. Now I click on a star and they all have randomized radiuses, okay? If we click on a planet, all the terrain is pretty much the same. So the last thing we have to do for this assignment is generate the terrain of a planet. All right. So let's go back to the README file and read what we have to do for planets before we get into this. Planet generation. After you have generated the properties of the star system, you then need to generate the properties of the planets within the star system. After each property has been given a value, you must then generate the terrain for that planet. Terrain generation is performed within the getTerrain function so that we do not generate terrain for planets which have not yet been drawn. So what that means is that when we generate a planet, that's not when we actually generate the terrain. We generate the terrain when we go to view the terrain in the user interface. Okay? So to generate the terrain, you must use the cellular automata method discussed in the slides. By default, the terrain grid holds a value of 0, which is drawn in the GUI as the color of the planet itself. Each cell with a value of 1 is drawn as dark gray by default. Therefore, the task of terrain generation is to set the values of the grid to either 0 or 1 to create an interesting terrain texture. The UI will use the integer in the grid to index the color vector within the planet in order to assign a color to a specific cell. See the bonus section below for details on how to get bonus marks. So what that means is, if I'm going to run the solution now. Whenever I go to a planet, the planet has been given a random color, right? That color is going to be used to draw the planet's terrain. A value of 0 in the grid here is going to be drawn as the planet's color, and a value of 1 is going to be drawn as dark gray. So that's going to be the same for each planet. Okay? See that? So this one is red, and the ones are here. So your job, essentially, is to take the planet's terrain array and put 1s and 0s in it using the cellular automata method. So if we go back to the code, or let me see if there's anything else in the README. Okay. In the README, here is the function getTerrain. Okay? So this is a function on a planet. So you are within the planet here. So let's go over and look at what planets have in universe.h. So the planet structure has a name. You are going to generate names for the planets. It has a terrain grid. So this is a grid of integers. That's the planet terrain grid. You're going to generate that. It has a seed. It has a radius, a number of moons, a terrain size, and some vector of colors. And then we're going to have these functions: getTerrain, getName, toString, and exists, whether or not a planet exists. So basically here, the most work for this assignment, because I just essentially did the assignment for you up here, showing you how to generate those random values. What you're doing mostly for this assignment is the terrain generation. So inside this terrain generation, there's this little check, and it just says, if the terrain's width is equal to 0, then we need to generate the terrain, because we haven't generated it yet. So this terrain function is called the first time I go to look at a planet. So for example, at this point in the UI, the terrain has not been generated yet. When I click this button to view the planet, that is when the terrain is generated, right? So every frame being drawn, this getTerrain function is being called by the user interface in order to view the terrain of a planet. So if it's being called every frame, we don't want to be generating the planet's terrain on every single frame. That would be really slow. So the first time we call this function, there's no terrain, so we generate it and then we return it. But every subsequent time, if the planet still exists, which it does right now, we're just returning the already generated terrain. So that's why this function looks like this. The very first time we call this function, we're basically saying, okay, we haven't generated any terrain yet, so construct the terrain grid and generate it. Excuse me. So here's how we do that. The terrain is just a grid, and you're already familiar with grids from assignment 1. So it's an integer grid which has the terrain size by terrain size. So it's a square of that terrain size on the planet. So the terrain size was randomly generated by you based on the planet's radius. Okay, so this here is the planet's terrain size, and so if that's 100, then the planet is going to be of size 100 by 100. So if I run this code again, you're going to see that if I click on any planet, all of the planets are going to be like 100 by 100, right? And you see in here that one planet, like all these planets, have cell 1010 is black. Why is that the case? Because what we've done here is set cell 1010 to black. So if I come down here and I set a few more to 1, so 11, 11, 12, 12, that's the same for every planet. So every planet that I visit will have that cell be set to black. So here, for example, we'll see those 3 cells are set to black. If I go to another planet on another star system, right, they're all set to black. So your job is to implement the cellular automata method that we had in the slides. So if I go over here to the lectures, remember we talked about this. So this algorithm right here, this do simulation step, you're going to implement this for some number of steps for each planet. So the grid, the old grid, what you're going to do is generate some randomness, right? Some random noise in the background. And if we look at, let me come back over here, generating random cave levels. Here's what we did, remember? So if we have the number of steps set to 0, at first your planet is going to look like this, and then you're going to do some number of simulation steps to refine your planet until it looks like something like this. Okay? So this whole algorithm here is going to be called within this function. So inside here, you're going to have your generate terrain function. Now you can create another function if you want. You can create any number of functions to help you with this. But essentially, the terrain generation is going to be done here. So let me do the first step of that for you, okay? So I'm going to write a random for loop, or not, I'm going to go over everything in the grid. So for size t I or x equals 0, x is less than terrain size, x plus plus. For size t y equals 0, y is less than terrain size, y plus plus. Okay, so now I'm going to generate a random value for each x and y location, but I want that random value to be the same for each x and y location for each time I view this planet, right? So this value here is going to be based on this x value, this y value, and the planet's seed value. So I'm going to create a random number like this. So auto r equals lamer2 x y, and then I'm going to mod that or XOR that with lamer with the planet's seed, because I'm currently in the planet class, so I can just mod that with the seed. Okay, or not mod, but XOR that with the seed. So it's taking the seed value into account for the planet to create a random XY value for this particular XY location in this planet. So now I'm going to take that and I'm going to say, let's mod that by 100. And I'm going to say if this is less than 40, then terrain.set x, y to 1. So what the hell did I just do? Hopefully what I just did is I created a random terrain where 40% of the tiles of a planet are going to be black for each planet. And they should be the same when I generate a planet. So let's go look and see if I did that correctly. So if I go to any planet and I click on it, here we go. So approximately 40% of these are ones and the rest are not. So this is the first step of that algorithm. And now you just have to run the cellular automata on it, right? So this looks suspiciously like this, right? So this looks exactly like this. And now what you have to do is run the cellular automata on that randomized data for some number of steps. Okay? So let's just look to see if my logic was correct. So if I click on this planet and I look at planet number 1, let's look at this random pattern. So it's 1 0 0 0 1 1 1. If I go over here, it's a different pattern. Yep. If I go back and look at this one again, it's 1 0 0 0 1 1 1. Perfect. So that means that I have a random number generator that generates random data based on this planet's seed and based on each X and Y location, so that it's the same every time I go back to that specific planet. Okay? So I'm not going to do any more for you because I've done a lot more than I did in previous years, but I just wanted to make sure you know how you would get, that data essentially, or that random number generation. Cool. So the last thing that we have to talk about is the setting of names. So the setting of names for a star system is very easy. You do whatever you want. So in the solution over here, what I've done for my star system, I've taken 2 random Greek letters and a random number between 1 and 1,000. So I have random Greek letter, random number between 1 and 1,000. You can do whatever you want as long as it's interesting. Okay? So in your get name function, you have to generate some sort of interesting name. I've seen like Lord of the Rings characters combined with, Final Fantasy character names. I've seen all sorts of character names. It doesn't have to be exactly like what I did. Just generate some interesting name for your star system. That's it. And you also have to generate names for your planets as well. Alrighty? So you have a star system get name, and then you have a planet get name somewhere. I can't remember. It's in there planet get name and star system get name. Below there, these are just the strings, the strings that are used to display to the user interface, so you don't need to edit those. Okay, I think I've covered pretty much all the functionality, so let's talk about the bonus stuff now. So the GUI description and controls. The UI has been implemented for you. Once stars and planets have been implemented, it will draw them and allow you to interact with them. Mouse controls. You can hold down the right mouse button while moving the mouse to scroll the view in either direction with a smooth deceleration. This works for both the universe view as well as the planet view. You can mouse over any star and it will draw the information about that star to be displayed in the UI in a small text box. So we've seen this already. You can left click on any highlighted star to display the information box on the top of the screen, which shows the entire star system and the planets. You can zoom in and out with the mouse wheel toward a targeted screen area. If you don't have a mouse wheel, you can use W and S to zoom in and out, okay, toward the screen. A and D will move the planet selector keys left and right. G will toggle the grid. K will do that saving of the view. L can load the view. Space key enters planet view mode when you have one selected, and escape key will exit planet view mode after you have a planet selected. Planet customization and bonus marks. All right, so here's something cool. Planet colors are stored in the colors vector of the planet class. These two default colors are color 0, the color of the planet itself, and colors 1, a dark gray color to indicate boring rocks. Also by default, the terrain grid of the planet class stores a grid of int values, indicating the color of the terrain to be drawn at that XY location. So what the hell does this mean? Well, if we go back over here to our getTerrain function, this terrain grid essentially holds an integer, right? That integer just tells the UI what color should be drawn for the planet. Those colors are stored up here in this grid. So by default, this is just like a red color that I've given you. However, let's do something here. So let's put another color. Let's say that I'm going to put a green color like this. So there's a green color now. And if down here, crap, 1 second. I want to go back to what it was before. There we go. So if I add a green color, and then down here, so the green would be in index 2 of this vector. If I add a green color down here, so if I go 2 and 2, then those should be green in the planet, okay? So let's see if that worked. Yes, it did. So you can see now that our planet has multiple colors, okay? So you can display colors on the planet in this way, or I'll talk about this in a second. So that's the way that you can display multiple colors in the planet. So to earn 10% customization bonus marks, you can. There are 10% of the marks for the assignment is for customization. To get those 10% customization marks, you can use multiple colors to create an interesting terrain view of the planet. Do this by adding more colors to the colors vector and by changing the integer values of the terrain grid. One idea may be to include some natural resources such as water, gold, silver, etc., which each have unique colors and may be found on various places and on the planets in interesting formations. So what one group did one year, which was really interesting, was they actually allowed you to walk around on the planet. So you can edit the UI in absolutely any way that you want. And what one group did is they had a little like white cell on the planet, and you were walking around on the planet collecting resources that they spawned in random locations. So that was really cool. For 5% bonus marks, if you really want to, you can implement Perlin noise for planet terrain generation instead of cellular automata. You can also make any changes you like to the user interface to make the game more interactive or fun, right? So essentially, in this assignment, you can do whatever you want for bonus marks. If you want to turn this into like an actual exploring planet version of No Man's Sky, go right ahead and do that. If you want to add enemies that you kill or points or whatever, if you want an easy 100%, do some customization for this assignment. And I think it's also really fun. Another idea to earn bonus marks is to incorporate time into your PCG for the star systems or planets. For example, you could oscillate the colors of the stars slightly to create a twinkling effect, or have certain features of the planet be based on the current time, such as a day or night cycle. One thing that one group did is they did Perlin noise to generate islands and stuff and water that I had that I showed in the last lecture. But based on a time variable, the water level was rising and lowering to actually create like a tide effect, which was really cool. So you can get 10% bonus marks for all of this, And it should be really easy to get full marks on this assignment if you get this working. So that's all the bonus stuff. Please, I highly recommend going absolutely, crazy with this assignment if you want to, or not if you have better things to do with your life. But it is pretty fun. I have a lot of fun looking at the bonus things. But I will show some of the cooler ones in class. I always love showing off student stuff. And if you make this look really cool, I will tell you that it looks really great on a portfolio if you're going to apply for jobs next year or something like that, to say, holy crap, this person actually like made No Man's Sky or something like that. All right, some hints. Of course, implement the star system class first, since that will be used first before you generate the planets. Get the default terrain generation working for the planet class before you attempt any bonus features. And you can add any number of helper classes or helper functions to the universe.h and CPP files, but just don't modify any of the existing variable names, because the UI uses those to draw it, okay? So for example, over here in universe, if you have a planet and let's say you want to have a player walking around on the planet, you could have int player x and player y. You can add all sorts of variables here, but please just don't change any of the existing variable names. Okay? So that's the assignment. It looks really complicated at first, but trust me, basically all you're doing is just in this function, you're setting some random numbers, okay, based on a range, and in this one, you're generating the terrain. That's really all there is to the assignment, but the explanation of all of that is a little bit verbose and complicated, because I want to give you all the information possible when you go to do this for yourself. So let me undo all of this before I hand out the assignments that have a bunch of solution code in it. Cool. All right, so I hope you enjoy the assignment. I always enjoy looking at the solutions that students come up for this one. I think it's really fun, and I hope you have a lot of fun with it too. So let's end on viewing this planet here. All right, great. And also the quiz will be available at 5, not at 3 p.m. So just keep that in mind. All right, thanks, and I'll see you in the next one.